Hey, grade 10s, welcome to the second last lesson we have in weather. Today we're going to be taking a look at recording weather information. What does it look like on a weather map and what does that mean to us? So a weather system is a set of temperature, wind, pressure, moisture that we're going to have over a period of days. For example, today as I'm recording this, it's hot and dry, but just a few days ago it was cool and rainy. It was also very windy. So this would be a weather system that is moving over us. One common weather system that we'll see is low pressure systems. Remember when we learned about lows, we said low means snow? Low pressure systems are systems that tend to bring cloudy skies, stormy weather. We can usually recognize them when we see the letter L on a weather map. This L represents a low pressure system. We'll also notice that the winds tend to circle in a counterclockwise rotation around a low. So backwards that the way a clock goes. This is often called a cyclone. High pressure systems bring clear skies and less windy conditions usually. We are at the beginning of a high pressure system right now, although it's a windy day today. The fact that the skies are bright and sunny indicates that there's a high pressure system. The wind spinning around the center of the high will be spinning clockwise. It's an anticyclone. We can tell a high pressure system when we see the letter H on the weather map. So you'll notice that on this weather map there are several L's and H's. The L's represent low pressure systems. Where we see an H, we have high pressure systems. Now, the color of the L or the H lets us know whether that we are having warm or cold weather associated with it. Not all lows are warm or cold, neither are all highs warm or cold. It talks more about the kind of weather we're having in terms of whether it's clear and sunny, which we'd see for a high, or kind of stormy and rainy or possibly snowy depending on the winter that we see for an L. On this map, because the L's are in red and are warm, I would assume this map was taken in the summertime. You'll also notice that on this particular map there are several little lines that are around the map in blue surrounding each of the systems. These are lines that connect areas of the same pressure. They are called isobars. The word iso means the same, and bar comes from the word barometric pressure, which talks about the air pressure that we have. So we have areas of the same air pressure together. Where these lines are close together, like we see here, this tells us that things will be very windy. We know wind always blows from high towards lows and then gets bent around the higher the low. Where we have areas that the isobars are very far apart, we're going to notice calm. We're not going to notice a lot of wind. And if we do have wind, in those cases, it will be very light. Sometimes we'll see lines that connect areas of the same temperature. We call these lines isotherms. Again, iso meaning the same, but therm from the word thermometer, where we talk about the same temperature. In this map, we can see where the sharp contrasts are between cooler and warmer temperatures. It's always interesting to note that the sharpest contrast that we notice between the highs and the lows often marks the location of the jet stream. Do you remember our jet stream? The jet stream is the river of fast-moving air that travels from the west towards the east. Sometimes we have north or south sections to it. It's a river of fast-moving air. Areas to the north of the jet stream tend to be cooler. Areas to the south of the jet stream tend to be warmer. And the jet stream marks the sharpest difference between the two temperatures. This is part and parcel of what people study when they study meteorology. Now, when these cold and warm air masses tend to move around us, they can quite often be identified by isobars and isotherms. We can tell where the pressure differences are, and that will help us determine some of the wind and whether the conditions will be rainy or clear. And the isotherms allow us to know whether the air associated with them is warm or cold. The edge of those masses are called fronts. So the edge of the moving air masses are referred to as fronts. When a front is a warm front, you notice that you will see a line with these soft red bumps that kind of go in the direction the front is moving. Because these bumps are on the top side of the line, this front is moving in this direction. They use red for warm, but they also use a shape because sometimes our maps are seen in black and white, and this helps us to identify it. The area behind the warm front is quite often warm because this is a warm mass. It's overtaking an area of cooler temperatures in front of the warm front. Obviously, if there's a warm front, we can also have a cold front. Notice the difference in the shape of the line. First off, the line is blue, which we associate with cold. But also you'll notice that the directional arrows now are sharp and pointy, and cold winds often feel sharp and biting. Again, this area behind the front is cooler. That's why it's the front of a cold mass. The area in front of it would be warmer. So this cold weather is moving in this general direction. Once in a while, we're going to find an occluded front, and this is what happens when cold air masses catch up to warm ones. They kind of overtake them. When a cold air mass catches up to a warmer one, quite often if we're having stormy weather, it will begin to weaken. We notice occluded fronts because their shapes quite often are the warm bump right beside a cold one, beside a warm one, beside a cold one. So we're going to have the bumps and the peaks and the bumps and the peaks. It still shows the direction that the air masses are moving. Sometimes, however, air masses actually move towards each other. In this case, we can see the cold weather moving in this direction, but it's being stopped by warm weather trying to move in this direction. All of this warm air is being held in place by all of this cold air, and this is why it's called stationary. The two fronts are pushing against each other, and in reality, nobody gets to move. When weathermen try to decide what's going on from the weather stations, like the one we have out at our airport, they will record the information with a bunch of little glyphs or pictures that look something like this. And these pictures talk about what the conditions are like at that weather station. We don't have to learn what all the different variances in these glyphs are. What we find more often that the weatherman forecasts it to us with is more conventional weather glyphs that are easier for us to understand. We can see if it's going to be cloudy or sunny, rainy or snowy, whether or not there will be lightning or hail with these kind of a series of weather glyphs. Weather glyphs like these are the ones that we most commonly will see when we go to one of our weather forecasting sites. We can tell whether or not it's going to rain or have lightning or be sunny. On a weather map, like the one we see here, we can see where there are highs and where there are lows. We have the highs with the H's and the lows with the L's. We can also see the location of the jet stream as indicated by the bright red arrow. I was missing one or two review sheets in your assignment package that I gave to you, so I've uploaded it to Teams. I'm going to have you guys work on the worksheet called Recording Weather Information to practice what we've discussed in this lesson. Also, tomorrow we will have our very last lesson for the weather unit on climate change.